Hi everyone. So today I am going to be talking to you about machine learning models and the architectures that go into building these models. So machine learning is everywhere today, from diagnosing diseases to powering self-driving cars to generating text and images. But behind the buzzwords are actual models and architectures that make all of this possible. In this video, I'll be going through the most common ones, starting from the basics and building up to the models driving modern AI as we know it today, in terms of ChatGPT and the large language models that we have access to. So before deep learning became popular, machine learning relied on simpler but powerful algorithms, and they're still widely used today. And the three main sort of algorithms are linear and logistic regression, decision trees and random forests, and support vector machines. So first of all, linear regression predicts continuous numbers, like, for example, house prices. And logistic regression is used when the answer is categorical, like whether an email is spam or not. And logistic regression will have a specific sort of S-shaped, and linear regression will just be the typical regression line going through the main part of our data points. With regards to decision trees and random forests, decision trees split data into rules. Think of sort of like a flowchart. And random forests combine all of these decision trees together to improve accuracy and stability. So random forests are I guess you can think of them as the plural of decision trees. So a random forest will have multiple decision trees, which will help the model improve its accuracy. And lastly, support vector machines are models that find the best boundary line or hyperplane that separates different categories in your data. So when you have all of your features on different axes and your data points, support vector machines will look into creating a boundary between our different categories. Now, these three models are fast, efficient, and form the actual foundation of many applications today in which we know AI is being used in, such as finance, healthcare, and data analytics in general. Now, on to neural networks. Neural networks is actually really what changed the game. As you can see here, this is a basic feed-forward neural network, and it has three parts. It has an input layer that takes in the data. So, for example, it would take in an image, and then you have the hidden layer that processes the data through weighted connections. And then lastly, you have the output layer that produces the final prediction. Now, these networks can approximate very complex functions, which actually makes them extremely flexible. And then there is the convolutional neural network, or the CNNs. And these are specialized for image and video analysis. And they work by applying filters across an image to detect edges, shapes, and eventually objects. So as you can see in this part of the neural network, or the CNN, as I previously said, there's an image as the input, and then there will be feature extraction in the form of detecting edges and shapes. And lastly, it will classify what object it is. And this is essentially the backbone of computer vision. And as you can see, this layered approach allows CNNs to recognize patterns like faces, handwritten digits, or even tumors in medical scans. CNNs are quite powerful and are mainly used for uh, different kinds of image segmentation and image analysis. Now, moving on to recurrent neural networks, or RNNs and LSTMs. RNNs were developed to handle sequential data, things like speech, time series, and text. Now, unlike regular neural networks, they have connections that loop back, giving them a form of memory. And LSTMs, or long short-term memory networks, improved on RNNs actually by allowing the model to remember important information for longer while discarding irrelevant details. And they were a breakthrough in natural language processing before transformers arrived. Now on to the famous transformers that brought us ChatGPT and many of the LLMs that we have in use today commercially. Transformers completely reshaped AI, and instead of processing information step by step like RNNs, they introduced the attention mechanism. The first time we heard about the attention mechanism was through a very famous paper, I think published in around 2017, called Attention is All You Need was the title. And essentially attention allows the model to look at an entire sequence at once and decide which parts of the input are most relevant. And as I previously said, transformers are the architecture behind LLM models like GPT, BERT, and many image generation systems. And they actually scale incredibly well, which is why they dominate state-of-the-art AI today. Now, lastly, to cover one of the more important topics in machine learning, sort of algorithms, is reinforcement learning, and this is another key approach to building models. So, basically, instead of learning from static data, these models learn by interacting with an environment. They try actions, receive rewards or penalties, and adjust their behavior over time. This method has been used to train systems that beat humans at games like Go and Dota, as well as in robotics and recommendation systems. So this is sort of a bit of a flowchart to sum up sort of the history of AI. Now, as I previously covered throughout this presentation, classical models came first with models like regression, trees, and SVMs, which are still widely used today. And then came the neural networks, which formed the backbone of modern AI. And then later, fast forward to CNNs, which dominate vision tasks, and then onto RNNs and LSTMs, which pioneered sequence modeling, and then the famous transformers, which now lead in language and multimodal AI, and lastly, reinforcement, which reinforcement learning in general, which powers agents that can act in the world and receive feedback in real time. Now, each model has its strengths and weaknesses. However, together they form the toolbox that is driving the AI revolution and that we can use for our various AI applications. If you found this video helpful, please make sure to leave a like, subscribe, and thank you so much.